In this brief chapter, we're going to cover the 3 Hadoop run modes. We're also going to investigate the purpose and the utility of each. Hadoop runs in one of the following 3 ways: local job runner mode, pseudo-distributed mode, which by default it installs into, or fully distributed mode. Here, these dark black boxes, as we see in other diagrams, each represent a physical machine. Inside of each of these machines, we're going to have one or more JVMs, or Java Virtual Machines, running. A common convention we use throughout this course is that a JVM is represented by a dotted line, as we have here with local job runner mode. In local job runner mode, we have a single JVM. Inside of this single monolithic JVM, we essentially create mock versions of all the daemons we'd expect, and we interact with them as though they were real independent JVMs. Local job runner, though, is just, again, a single monolithic process that shares all the heap and all the variables inside of a single JVM. Pseudo-distributed, again, is the version that Hadoop installs by default. This allows you to install all 5 independent JVMs inside of a single machine. Here we use the common convention of blue as HDFS and green as processing, and we see the 5 daemons we'd expect. The 3 master daemons, the name node, the secondary name node, and the job tracker, and the 2 slave daemons, the data node and the task tracker. Again, all of this runs inside of a single machine. There's a lot of benefits for doing things this way, and we'll talk about those in upcoming slides. Next up, we see what we would have in a real production cluster. Here we have a 4-node cluster, or 4 slave machines, and 2 master machines. Each of the 2 master machines houses a subset of the daemons, with one machine housing our name node and our job tracker daemon, and another machine housing our secondary name node daemon. On each slave, we have a data node and a task tracker, again providing the storage and the processing in blue and green. To show the advantages of pseudo-distributed and fully distributed, it's important to talk about the task spin-up that's involved. Over here on the left, we have our name node and job tracker machine, and a single data node and task tracker machine. When a job spins up, the job tracker machine tells one or more task trackers to run an individual task. Each task tracker then stands up a brand new Java virtual machine, and each task tracker is going to run multiple tasks. Standing up a JVM is a rather expensive process and will at the very least take a few dozens of seconds to accomplish. After each map or reduce task is finished, each JVM that was running that task is shut down. Again, this applies only to the pseudo-distributed and fully distributed, but it basically means that each JVM create and teardown is going to require a few dozen seconds. This task spin-up and teardown is an important part of why there are 3 run modes in Hadoop. Let's talk about the advantages of each. Again, local job runner uses a single monolithic process, and because it's not standing up these tasks, running a local job runner job is only going to take a few seconds. It's very useful for doing local code debug on the developer's machine, as well as testing code. It can be run from inside many of the IDEs such as Eclipse, NetBeans, and IntelliJ. Next up is pseudo-distributed mode. Again, because it's standing up these individual map and reduce JVMs, the fastest pseudo-distributed mode is going to run in tens of seconds. For developers trying to debug only their code, this isn't a viable option because it's standing up those JVM tasks individually. But it does let developers test their code in a quote-unquote real environment with several daemons talking to each other just the same as they would in a fully distributed cluster. In addition to testing code, pseudo-distributed is very useful for testing data. We may want to check for missing and malformed records and make sure that our MapReduce code works when it finds one of these records. Both local job runner and pseudo-distributed are often found running inside of a virtual machine on a user's workstation. And once a user is happy with how their code runs in local job runner, they typically use pseudo-distributed to test subsets of their data, typically 3 to 5% of the overall data dump. Obviously, there wouldn't be any advantage to using Hadoop on a single machine. So once we're ready to process our actual data, we move on to the slowest run mode of all, the fully distributed, which involves several machines in a large cluster. This obviously may take hours or days to run. But even before we run on the full data set, oftentimes developers will decide to run on test subsets of the data, maybe 10 or 20% of the data. And again, the biggest value of this is being able to run a full production job. When running a job, it is extremely beneficial to push your code and your data through these three separate modes, letting developers work on their individual workstations on local job runner and pseudo-distributed mode, and only occupying valuable cluster resources once we've tested the code and tested the data. And maybe even once we get to production, we may want to run with test subsets of our data. For individuals looking to build these test data sets, that 3 to 5% or 10 to 20%, it's highly recommended that you go through a random sampling of the overall data set. For example, don't just take the first 3 to 5% of the records. Instead, sample every 16 or 20 lines throughout the entire file. Again, in this chapter, we looked closely at the three run modes, local job runner, pseudo-distributed, and fully distributed, and we investigated the purpose and the utility of each.